I am Anil Kumar. Welcome to my series on advanced functions. We'll discuss bounded and unbounded interval in this particular video. Now, this video is very important for those who are taking pre-calculus and who will be doing calculus in coming time. We'll discuss bounded interval, unbounded interval, number line and interval notation. We'll write inequalities as intervals, the solution in intervals. We'll write areas in interval notation. We'll simplify intervals and solve some inequalities. That will really help you to understand how to write domain, range, and at times solution of equations with interval notation. So let's begin with the bounded interval. So as the word signifies, which is, we'll discuss first what is bounded interval, and then we'll go to unbounded interval. So when I say bounded interval, it means what? Let me write out. When we're talking about bounded means we have a boundary condition, right? Bounded interval. So this interval has a finite length. Correct? So that is how we could say what is a bounded interval. Now, whenever you talk about bounded interval, we could have two, rather three, four varieties of this. But major thing is that it could be an open interval or it could be a closed interval. So let me differentiate the two. Absolutely, let's make it very clear. So when we say that the value of x is greater than, let's say, a, but less than b. So in that case, a and b are not included, right? So on a number line, let's say that is the number line. On a number line, we could mark 2 points A and B with holes or not filled circles, and X is somewhere in between but not including A and B. That's what it really means. Now, this is also called as an open interval. This open interval has a boundary and a limited boundary, so it falls under the category of bounded interval, right? So we could have another condition saying that the value of x is between, let us say, C and D, but this time both points are included. So on a number line, we could actually indicate this using filled in circles. So we sometimes use the word filled in circles. So there, C and D both are included. Right? So this is also referred to as closed interval. Correct? Now, in interval notation, we could give intervals in terms of these signs, which are in terms of inequalities. Or using brackets. So we could also write this as a circle bracket, A comma B. So that means from A to B, A and B not included. And here we could write with a square bracket, C to D. Now that means that both C and D are included. Okay, so these are interval notations. So we refer to them as interval notation, right? So let me write down this as interval notation. Correct? So you could also give it in this form. Now, since we have talked about open interval and closed interval, it is good time to also talk about half open interval. So what does that mean? Well, as the name suggests, we could have something like this on a number line where we could say that one side is not included, but the other side is included, right? So that could be an interval in which one side is included. So let's say these points are, let's use a different ink here. Let's say these points are P and Q. Then we could write this as P to Q, where Q is included. Now we could also have an interval which is included on the left side, but not on the right side, kind of like this. Right? So that kind of an interval could be written as, let's say it is m to n. So in this case, m is included, but n is not included. Well, that could be a part of our solution. So we could also add them up, saying this union that. So both are possible, correct? So you could use this kind of notation. Now here, what we have used is half interval. So in half interval, one side is included, right? So both sides, both ends not included. In this case, both ends included. Now here, one end included. You could also divide it into two. Left is included or the right is included. And it could be shown in this particular way. So I hope this part is absolutely clear. Now, in general, we also write this in the form of a set notation. So where we can say that the interval is a set of all the numbers where x belongs to set of real numbers, where you could say x is greater than equal to, let's say, let's use C and D, kind of like this. So when you use these curly brackets, in that case, these curly brackets designate the set. Is that clear to you? So these are some very important terms which will be commonly used while you're discussing about domain, range, and providing answers in a particular form, which could be set notation, which could be interval form, which could be a number line, as we have seen in this particular case. Now let's move on and see what is unbounded intervals. So in unbounded, the interval is not finite. So if the interval is not finite, then we're talking about unbounded. Clear? Now the cases could be that, well, let's take three cases which are very common. So one of the case could be that interval one side. Let's say we have something which is on the left side of A, for example, correct? So that is an infinite length, right? Or we could have from, let us say, point B to infinity, or we could have, both sides. Now, of course, these points could be included, could not be included, right? So as the case may be, of course, you cannot never include infinitely large value. But you could write them as, this could be written as from minus infinity to A, where A is not included. Here we'll write it from B to infinitely large value. In this particular case, it is from minus infinity to, let's say, C, where C is included, infinity is never included, or it is from, let's say, D to infinitely large value, which will never be included. So these are your unbounded intervals where one of the limit is approaching infinitely large value, or both could be approaching infinitely large value, as you have seen here. Now at this stage, I'd like you to understand that whenever you write an interval between points A and B, in that case, remember that the point A is less than B, right? So that is kind of important to understand. So that is the correct notation. Correct? So what I'm trying to say here is that if I give you an interval, let us say from -3 to let's say 2, and then from let's say 5 onwards, where 5 is included, something like this. And here I say from 3 to 2. So in that case, you have to write that 3 is included, -3 is included to 2, correct? Union, we have 5 to infinitely large value. So if you write like this, then it is correct. However, if you interchange and you write like this, 2 to -3 union, let's say you keep this as such also, that will be incorrect since this order is not correct. So always, whenever you write, it is to be written where it is from left to right. Is that clear? That is the interval. Now, with this in mind, I'd like you to write down the solution for this particular question. So take it as a practice question, right? So now we'll have few practice questions. I'd like you to pause the video, answer this particular question. We have shown an inequality in the first column, and the second column you need to write the interval notation, and in the third one you have to write the number line to represent the solution for the inequality, correct? So take your time to do it. I'm just drawing these lines here to give you some more time, and I hope by now you must have got some of the solutions, correct? Now let's try to put interval notation here. So when I'm saying x is less than equal to 5, that means it is unbound, right? So it's going up to minus infinity, but it is going from 5, which is included. Do you see that? On a number line, we will say that 5 is included and it is heading towards negative infinity. So we'll write 5 here and show the arrow going towards negative infinity. The second one is that x is greater than equal to minus 3, but x is not equal to 0. How will you do this? Well, it means x is not equal to 0 will be a circle which is not filled in, and this will be at 0. Now we are saying that x is greater than equal to minus 3. Minus 3 will be, let's say, on the left side, so that is minus 3. And greater than means we are moving towards the right hand side. So it is from here to there, up to 0, and then like this, where there is a circle which is not filled in at 0. Perfect. That is how we are going to write. In the interval notation, we could show this by including minus 3 and excluding 0, right? And then union, excluding 0 till positively infinite value with a bracket, which is a circle bracket. Perfect. So that is how you're going to show it on the interval notation. The last question here is x is less than equal to 10, but it is not equal to plus and minus 5. So that means that these points which are minus 5 and plus 5 are not included. Show them with an open circle on a number line. But say it's less than equal to 10, so 10 is included and you're moving towards the left side. Do you see that part? So that is how on a number line you're going to provide the solution. Here we're looking into all the values from minus infinity to minus 5, and then from minus 5 to 5, and then union from 5 to 10, where 10 is included. So there will be a square bracket here at 10 as you have a filled in circle on a number line. Is that clear to you? Perfect. So that is how you have to provide the solution in this particular case. Now let's take, I'll just give you one here, the reverse way of doing it. So on a number line, I'm going to mark an interval and I will like you to provide these two parts, which is write an inequality or and write interval notation, right? So we'll keep it like this, that we'll have something which is included in between these points and then beyond this and also beyond this, correct? So I like you to write an inequality which gives you this solution. Let me write down the value of these points as -2 and let's say 4. Perfect. So that will be your question. Now let's take the next question here, which is write area in simplified form. Now in this particular case, we have given you a mixed kind of an interval. Normally, it should not be written like this. We have to always simplify and write our answer. So note here is that always simplify to provide solution. Is that clear? So that's a must, right? So at times you may land up in a situation where you may get something like this as shown here. You need to simplify and write down as a simplified answer. So we'll write the simplified form here. I'd like you to pause the video and answer this particular question. So the first one is -5 to 10. Now this symbol here is intersection, which means common, or you can say overlap. That is what it means. So what is overlapping between the two intervals? So let's try to see it on a number line itself. It's easier to visualize. And then we'll actually provide the solution. -5, let's say this is -5 to 10, both are not included. Let's say this is 10 for us. And the other one is from 3 to 15. So let's say 3 is also not included to 15, right? So that is the kind of thing. So clearly, the portion which is overlapping is between 3 and 10, correct? So that is your solution, the thing which is overlapping. And therefore, I could write this solution as between 3. Now 3 is not included and even 10 is not included. So we'll write this 3 first and then 10. Is that clear to you? That is how we are going to write. So let me write it here also. This is equivalent to saying from 3 to 10. Is that clear to you? Right? And on the number line, you will show it like this. Perfect. The next one is -3 to 7 and then from 7 to 10. Now as soon as I write like this, 7, plus we have U. U is for union. It is as good as also saying or. So both will be included. Do you get the idea, right? So here what we get is particularly, we could write this as from -3 everything till 10. So that is what we're trying to say. On a number line, if I have to show this, in that case, the first part is from -3 to 7. So that is -3 and this is 7. The second part of this is from 7, where 7 is included, filled in, to 10. You get the idea. So the solution here is all in between. Perfect, as shown here in the interval notation. So that is how you're going to do it. The last one here, I'd like you to pause the video in this case and do it. Intersection, that is also called as and, right? So it has to be common. So the first one here is from minus 5 towards the left side. So let's say this is minus 5. We are saying from minus 5 towards the left side. And the second one is between minus 7 and 7. So second one is between minus 7 and 7. So this point is 7 and this is minus 7. What is common in between? Well, clearly, this is what is common. So we could write this as minus 7 to 5. Correct? Minus 5. So that becomes the common thing. And that is how we are going to show it. Is that clear to you? So when inequalities are given to you, you could represent the answer on a number line or in interval notation as we just seen. Now here are 3 test questions for you. You need to solve inequalities and provide solution in interval notation, right? So it could be solve inequalities and there could be provide solution. There could be many options here. Option A could be number line. Option B could be interval notation. Option C could be bracket notation, right? So interval notation is also called set notation. Okay. So you could provide answer in any of these 3 ways actually, if not specified. Okay, so the 3 questions for you are, let's begin with the very first one, which is we're talking about minus 7, which is actually less than x plus 1, which is less than 5. So when we say solve inequality, we have to figure out what is the value of x. So to solve this, we'll take away minus 1. So we can write this as minus 7 minus 1 is x plus 1 minus 1 and 5 minus 1. We'll take away 1 from each part. Then we get 8 and x in between 5 minus 1 is 4. So that becomes our answer. Now this answer you could represent on a number line as the interval. So this is a finite interval, bounded interval between minus 8 and 4, right? So we have from minus 8 to 4, which is not included. You could also write this as, the bracket should be circle, not the square bracket, as minus 8 to 4. Or you could write this in set form that x belongs to real numbers where x is greater than minus 8 but less than 4. Is that clear to you? So these are different notations in which you can provide solution for inequalities. And many times, even for domain and range, that is how you have to write down the answer. Let's take the solution of the next question on a fresh page. So this time, the question for us is 2 times absolute value of x minus 3 is less than equal to 13. So let's add 3. So we get 2 times absolute value of x minus 3 plus 3 is less than equal to 13 plus 3, which is 16. So we get 2 times absolute value of x is less than equal to 16. Absolute value of x is less than equal to 16 divided by 2. So we get absolute value of x is less than equal to 8. Now what does that mean and what should be the answer? This is very critical to understand. So when we say absolute value means it could be on either side, right? So plus or minus. So really speaking, if you are looking at 0 at this point, we are just saying that x value is between plus and minus 8. So that is how you have to interpret this particular solution. So in this particular way, we are including the point minus 8 and also the point 8. So the solution basically is, you could also write this as x is between minus 8 and plus 8, or you can say x belongs to the set of real numbers where x is between minus 8 and plus 8. Or in the bracket form, it could be written as minus 8 to plus 8. Is that clear to you? So those are all the forms of solution. Correct? So I'm giving you all forms of solutions so that in the test you could write whatever is really required. Perfect. So I hope you've understood how to write solution for absolute function. Next one is related with square. Now in square also, it's kind of absolute function. When we'll get to it, you will understand. So let's try to simplify this inequality, which is x plus 2 whole square plus 1 is greater than equal to 17. Let's take 1 on the other side. So we could write this as x plus 2 whole square is greater than equal to 17 minus 1. Or we have x plus 2 whole square is greater than equal to 16. And now we'll do square root. So next step here is to square root both sides. Now this is a very critical step, and many times we have seen students making mistake at this particular juncture. How do we correctly understand which is our solution? Now let's try to understand with the help of the graph of x plus 2, right, whole square and something greater than 16, right? So think about it like this. We have a graph of a parabola and we are saying that we're looking for some portion which is greater than or equal to 16. So somewhere above like this, right? So only the portion which is on the other extremes going away is the solution. Is that clear to you? So that becomes the solution. Now since it is also included, we'll fill in the circle. So that portion is filled in. And this point clearly is plus and minus 4, right? So remember, square root of 16, basically you will do plus and minus and you get plus and minus 4. So these points are actually at minus 4 and plus 4. Perfect. So what is our solution? On a number line, I have already shown you the interval, which you could write as, let me write down solution now. So solution I could write as from minus infinity to minus 4, and or rather I should say union from 4 to infinitely large value. Since we have greater than equal to, 4 should be included. Is that clear to you? If we exclude 4, then the answer is incorrect. So that becomes the exact solution for the given situation. Perfect. Now at this stage, I'll also like to tell you that we could always test a result. So we call this as a zero test. Now this is a very important step. It doesn't take much time. So we have to see whether 0 is a part of solution or not. So the question is 0 a part of solution? So that is the question. In our case, the answer is no, right? So in our case, the answer is no. Since 0 is not included, 0 is somewhere in between, right? So what we do here is, to check, what we do here is substitute 0. So when you substitute 0 here, we get 0 plus 2 whole square plus 1, and that is indeed equal to 5. And we know 5 is not greater than equal to 7. So 0 is not solution. Is that clear to you? So that confirms that our answer is correct. Is that clear, right? So that is how You could easily do a zero check of your result and then figure out. So getting back to the next previous equation, 0 is a part of solution, right? So let's do zero check here. So if I substitute 0 here, I get 2 times 0 minus 3, and that is indeed equals to, is less than equal to 13. That is correct. Do you see that? So zero test should be performed whenever we do it. Now here also we have 0 as a part of solution. So if I substitute 0 here, I get minus 7, 0 plus 1, 5. And clearly, when we write like this, it makes sense. That is true. That means 0 is a solution. Of course, inequalities will have infinite number of solutions as we have seen in this particular case. But testing one point, which is 0, is simple but actually confirms the answer. So it should not be avoided. So I hope with this you have understood what really the interval notation is, what is bounded. Bounded means finite, but it could be open or closed, right? So basically it could be open or closed, or it could be even half of this, right? As far as unbounded means, is it approaching infinitely large value, which could be positive or negative? On a number line, we can always check our results, so we could always write down number line and show the, the intervals. A circle which is not filled in is for the open interval. But if we have a circle which is filled in, then in that case, that will be a closed interval. Perfect. So that is basically bounded intervals. You understand what is unbounded. When we say unbounded, we are saying that one of the or both could be leading to infinitely large values. So that is unbounded. Perfect. So that helps you. Second, as far as solving the inequalities is concerned, we talked about zero test. So it is easy to check if 0 is part of solution or not. Is that clear to you? So if you keep these things in mind, I think you'll do far better on this particular topic of bounded and unbounded intervals. And this is extremely helpful since we're required to provide answers in this particular notation, right? So we also learned two notations, set interval notation and the bracket notation. Perfect. So with that, we close this particular video. I hope it makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.